Next, I'm going to take a look at trigonometric ratios. The very first thing we need to learn is sine, cosine, and tangent, which are terms for equations that we can use to find the angle of theta, amongst other things. And this is why I emphasized before that the terms adjacent, opposite, and hypotenuse are important to memorize and remember, because they make up the values of sine, cosine, tangent. As you can see, like each of the equations use hypotenuse, opposite, adjacent, and all of those values. So first I'll start with sine, and the equation for sine is the value of the opposite over the hypotenuse. Next, the value of cosine is the adjacent over the hypotenuse, and finally for tangent, it's the opposite over the adjacent. And you just kind of have to memorize these things. And a good rule that I would use to memorize these equations is SOH CAH TOA, which basically is showing you sine opposite hypotenuse, cosine adjacent hypotenuse, and then tangent opposite adjacent, just letting you remember the order of things. And I would just memorize these equations as best you can to avoid any mistakes with your math. Moving on, I'll provide an example of how to use these equations so that you can move on and attempt some practice problems without help. Okay, so next is the example question. So for this question, I'm asking you to find the value of theta in a triangle with a hypotenuse of 2 and an opposite side of 1. So to kind of put it into perspective, it's this equals 1 and this equals 2. And I'm asking you to find the value of this angle. Now, looking at the sine, cosine, and tangent rules, we can see that sine of theta is equivalent to the opposite over the hypotenuse. And since we have both the opposite and the hypotenuse values, then we would just set sine theta equal to 1 over 2, which is the opposite over the hypotenuse, and simplify that to be sine equals 1/2 or 0.5. Then you would move sine over from the left to the right by taking the arc sine or inverse sine of the angle theta, because all we really want is to have the theta alone so we can find the angle. We don't necessarily want sine around theta. And to do that, you need to take the arc sine. You can't just like divide by sine. It's a very specific action that you would require a calculator or a good memorization of sine and arc sine values. And by doing that, you would then find that the angle theta is 30 degrees. Okay, so here's a question for you to try on your own. It's a bit more robust than the example I showed, but using your knowledge of Pythagorean theorem and now sine, cosine, and tangent ratios, you should be able to reason the question out. Okay, here's my explanation for question 1. Hopefully it went well, but I'm going to give detailed explanations to ensure everyone understands. So for the first question, I asked you to find the value of just cosine of theta for a triangle with a hypotenuse of 13 centimeters and an adjacent of 5 centimeters. And to do that, you really just plug them into the equation. Cosine is equal to the adjacent over the hypotenuse, which would give you 5 over 13. Okay, so the next question, I was asking you for the value of theta, and as I explained before in my previous example, to find the angle, you must use an inverse cosine to separate theta from the cos, which would require you using arc cos. And then, as I show you here, you take cos inverse of 5/13 to get theta, and that would set theta equal to 67.4 degrees, and then that would be your answer for that question. Okay, so part 3 of question 1 requires us to go back to Pythagoras' theorem, which, if you recall, can be represented by the adjacent squared plus the opposite squared is equivalent to the hypotenuse squared. And then by using this format, we can just plug the 5 and the 13 in to the equation to figure out what b would be, which is the opposite side. And so what I did is I expanded out the 25 and the 169, and then to isolate b, I subtracted 25 from both sides, which would give me 169 minus 25 is equivalent to b squared, as you see here. And then that's 144 equals b squared. And then when you take the root of b, it's giving you the root of 144. So b would equal 12, as you can see here. Okay, now for the final 2 questions, it was really a matter of remembering the equations for sine and tangent that I gave you. If you recall back to SOH CAH TOA, the acronym that will help you memorize this, you see that sine is the opposite over the hypotenuse, which is 12 over 13, and that's how I got that answer. And then the tangent is equal to the opposite over the adjacent, which is 12 over 5, which is how I got that number, and that's the answer for both of those questions. I hope you made it through the first question okay. Moving on to the second question, I've added some twists to allow you to expand your thinking and learning on Pythagoras and trigonometric ratios. Here's question 2. Please pause and take time to solve, and I'll explain it on the next slide. All right, for question 2, the very first problem I gave you was to find the length of the adjacent side of the right triangle that has an angle of 30 degrees and a hypotenuse of 10 centimeters. So the very first thing that you must do is calculate what cosine of 30 is. For this, you can either use a calculator, memorize the unit circle, or going back to that 30, 60, 90 triangle from before, if you use those ratios, you can also find the answer to cosine of 30. So in this case, I'm just going to give it to you. Cosine of 30 is going to be root 3 over 2. And then once you have that, you set root 3 over 2 to the adjacent over 10. And what we want to do in this problem is we want to isolate the adjacent side because that's the side we don't know and that's the side we're trying to find. So what you would do is you would multiply root 3 over 2 by 10 equals to the adjacent, which is what I did. And then by simplifying all of that, you will see that the adjacent is equivalent to 5 root 3. Next, for part 2 of this question, I asked you to find the value of the length of the opposite side. Now, there's 2 different methods you can use to solve this. If you remember back to Pythagoras' theorem, you can use the hypotenuse length and the adjacent sides to calculate the opposite sides like this using the a squared b squared equals c squared method, or you can use sine instead of cosine to find the opposite side. However you do it is really up to you. Since I've already covered Pythagoras' theorem quite a bit, I'm going to let you decide whether you want to do that, but I will walk through the sine method with you. Basically, the second method would be to set up your problem the same as you did before for the adjacent side, but remembering that sine is how you obtain the opposite. So instead of going cosine where it's adjacent over hypotenuse, you'd go sine where it's opposite over hypotenuse. And since you still have the hypotenuse value, you can still find the opposite side just given the hypotenuse and then the angle. So what you do is you again set sine of 30 equal to whatever it is, which in this case is 1/2, and then that's equal to the opposite over 10. Then by moving the 10 over to the other side through multiplication, giving you 10 times 1/2, that's going to be equal to the opposite, and that would give you 5. So in this case, the opposite is the value 5. And then if you look at the first method, you can see that we got the same exact answer using Pythagoras' theorem, which really just checks to make sure that we've done this correctly. Moving on to the next part of this question, I asked you to determine the shortest and longest sides. This question was supposed to be very simple and self-explanatory. I just wanted to help you visualize the side lengths and trial configuration. So based on our calculations of the adjacent and the opposite, it's clear that the shortest side is the opposite. And then by using the knowledge we gained earlier, knowing that the hypotenuse will always be the longest side, we can make the assumption that that will be the longest side. And then also, if you look at it mathematically, the hypotenuse is 10 centimeters and the opposite and adjacent are both around 5 centimeters. So it's definitely the longest side. Okay, and finally, I asked you to calculate the tangent of the triangle. This one is also supposed to be kind of just a simple way to help you remember trigonometric ratios. So for this, all you needed to do is remember the equation for the tangent, which is the opposite over the adjacent, as I have it here. And then if you plugged in the values correctly, you would get 5 over 5 root 3 because the opposite is 5 and the adjacent is 5 root 3. And then through simplification, you would find that it's 1 over root 3, which can also be represented as root 3 over 3, but both answers are perfectly correct. Okay, now that I've finished the second question, I'm going to reinforce the topics we just learned as they pertain to trigonometric ratios before moving on. After doing these 2 questions, I hope you will have a better overall understanding of trigonometric ratios and how they can be used in mathematics. Some key takeaways I would definitely remember,
just as for Pythagoras, is that these ratios only really work directly on right triangles, and that's something you really should not get mixed up. It's a good rule of thumb as well to remember that the hypotenuse is the longest side of the triangle, and also memorizing the term SOH CAH TOA to help you remember sine, cosine, and tangent ratio equations will be imperative in learning how to use them. Finally, it's important that you have working knowledge of how to represent and calculate angles with sine, cosine, and tangent. Unless the angle is simple, you will always need a calculator to find the angles. So it's also good to learn how to use and define arcsine, otherwise known as inverse sine, because it's the only way to take the angle out of an equation. So that's going to be it for the explanation on trigonometric ratios. I hope this made sense. And now I'm going to move on to explain obtuse trigonometric ratios, which are closely tied with this concept.